Hi, this is Sasha Poquet, and this is a summary video for the first module of the Social Network Analysis MOOC as a part of Learning Analytics series. Yes, a summary video, and that means that I will go over the main takeaways that you should have had after finishing the first module. I will not be explaining the concepts, because you can find explanations of them in books, extended notes, and papers. But I would like to emphasize the main points that I hope you have achieved, having gone through some parts or all the totality of the materials we put together in Module 1. So, there are two main takeaway messages. One, there is a whole bunch of important formal concepts that you need to understand. So if you hear a term that I will be using and you do not know or you're not sure what it means, you need to go back to the materials and make sure that you do know what it means. And the second important takeaway is that all these terms refer to formal graph concepts, but the meaning of them in the context of your network will be very different. So interpretation of the metrics of the formal graph concept differs depending on the context. So let's start with the basics. There are different types of network relations. The ties between the nodes in the network can be directed. I speak to somebody, there is a directionality. They can be undirected, so two people that are located in the same room do not have any directionality between them. The ties could be signed. I can like somebody or dislike somebody. The ties could be valued. I send 15 emails to one person and I send one email to another, meaning that my email tie to that person is weight 15 and to another weight 1. Ties can be multiplex. For instance, I have a friend with whom I go to the movies, and same friend that I trust, but I have another friend with whom I always only go to the movies, but I don't trust that friend very much. So my relationship to the friend could be having these multiplex ties, meaning that there are different definitions of or meanings of the ties that underpin our relationship. There are different types of networks. Some are ego networks where you're looking at all the relationship from the perspective of the central node. Some are whole networks, meaning that you're looking at everybody who's, for instance, communicating within a classroom. There are one-mode networks where all the nodes are of the same kind, and there are two-mode networks where the nodes represent two different kinds. For instance, people who are sitting in the same department, the department could represent one type of node, and the people are a different type of node. Multi-level networks is where you have a network at different levels. For instance, the trees that talk to one another is one level, and the birds that interact with these trees is another level of the network. The network data can be archival, observational, or reported. That is, you take your data from somewhere, it's already been there within some kind of system, or you ask people about the relations and the definitions of the tie. The network can be represented in different ways. It can be an adjacency matrix or an edge list, and adjacency matrix for directed or undirected networks is slightly different. Finally, there is a set of basic graph metrics, such as density, distance between the nodes, which you may know as the 6 degrees of separation, for instance, represents some kind of distance or hops between the different nodes within the network. There are shortest possible paths within the network, connected graphs or graph components, the diameter, and degree distribution and its shape. These are very basic things that you need to understand. So I have a little kite network there on the slide that helps you remember the different things. But when it comes to interpreting these different metrics within the graph, you have to ask yourself a question. What does that metric mean in a context of the phenomena that my network represents? So what if a tie means that two nodes are friends? Or what if a tie means that two people replied to the same hashtag? Or what if the tie simply means that two people borrowed the same book from the library? The density of a network of friends will not mean exact same thing as the density of a network of people who borrowed the same book from the library. Interpreting these metrics would imply different things, and sometimes interpreting these metrics would actually be a little bit nonsensical. The next important notion in network analysis is centrality. In short, which node is important. If you went through the extended readings, you know by now that there are very different ways as to how one can be important within a network. So it could be that you're important because you're connected to a lot of different nodes. That would be your degree. It could be that you're important because you're close enough to everybody. In terms of the distance in the network, that would be your closeness centrality. It could be that you're important because you're actually sitting between two different groups of people who do not talk to one another, so your betweenness centrality makes you a very important node because those two groups give you exclusive pieces of information. And then finally, you may be important not because you're connected to many people, but because you're connected to somebody who's very connected. And so if you do not remember what these things mean, it would be a good idea to go back to the slides and use the kite network as an example that demonstrates very well how node D is central based on its degree, but how node H is central based on its betweenness, and how nodes F and G are important because they're close to everybody else. And again, the most critical question to ask is, when you know these centralities for each node in your network, what does that actually mean? Does that actually have the impact that you think it has, given the context of your network? For instance, betweenness centrality is a very easy example to understand. Normally, betweenness centrality is associated with this unique positioning, where you're exposed to unique information from different parts of the network, for instance. And that notion comes from networks that were self-reported, which means that in most instances, those different groups do not actually communicate with one another, and you are, in fact, in a unique position. But what if betweenness centrality represents something that comes from an online network? Just because somebody has a high betweenness centrality in a forum between the two groups that seemingly do not talk to one another, it does not actually mean that the group on the right cannot read what the group on the left has said. So the exclusiveness of information that belongs to one of these groups is no longer only centered on the betweenness, on the node with high betweenness centrality. So in that sense, remembering what your context is very, very important in terms of what you're getting out of your metrics. So again, two important messages after Module 1. First, make sure you know the definitions and you understand on some intuitive level what the formal graph concepts mean. And two, make sure that you really understand what your network represents and how that context helps you interpret these metrics. I'll see you in Module 2.